Thank you. It's an incredible leap of faith to have actual glass bottles here, so if you start heckling and throwing them, I'm going to be quick on my feet up here. Usually my contract rider would insist on plastic bottles, but we'll go from here. All right, so I lead more security teams than you would think actually exist at Etsy. Do a wide variety of stuff from AppSec to NetSec to developing user-facing security features. And then risk engineering team kind of focuses on how do you detect bad actors in a marketplace, whether that's your traditional sort of spamming stuff and financial fraud to kind of sock puppet accounts and things like that. Formerly, very proudly at ISEC Partners, several of which people who are here today, so they may either lead the cheering or the booing depending on how I'm doing. What is Etsy? Like I said, creative, independent businesses. What's a little bit more interesting is kind of what is the scale of Etsy. So the things I'm going to talk about today have applied at a scale of this. Lots of the techniques I'll talk about apply at higher scales and at lower scales as well. What I actually want to talk about today is not so much kind of security theory and how do you go about doing things in a very conceptual manner, but what are incredibly simple things that you can do that are actually very effective as well. So I will actually feel very happy if a number of the things I talk about, your first thought is, wow, that's kind of dumb, but in a good way, right? That it is a very simple thing to implement that actually works. Awesome, let's try it out. So like I said, simple and effective. I forgot to say this up front, totally interrupt with questions, stuff like that, makes it more exciting. Awesome. So, and a few slides in and I break it. Awesome. This is why no glass bottles. All right. Hitting escape works. That's cool. Awesome. So one of the things that Etsy is probably most famous for in the engineering space is something called continuous deployment. So actually, out of curiosity, how many people have heard of continuous deployment before? Kind of know what that is. This is awesome. Okay. So what it's hopefully not is just wildly pushing to production and hoping the pager doesn't go off. We've all been in environments like that. It's quite exciting. What continuous deployment is all about is about iteration, right? How do you make small change sets that you define as very low risk, not in a security sense, but in a sense of breaking the application? And how can you very quickly iterate on that? Because the culture that you're trying to get to there is one of just shipping, right? This is make a bunch of t-shirts with this stuff on here. But really what you're going for on this is how can I make very fast, frequent changes that I feel will be low risk to the environment? I don't have slides in here on this, but one of the things that really makes this possible are things called config flags or feature flags. And that's where what you do is when you're pushing code out into production, you have that like block of code wrapped in a feature flag, right? So you have like your code wrapped around essentially a giant if statement, right? And if that feature flag is actually enabled, then that code runs. If it's not enabled, it doesn't run. And where this is actually powerful and lets you do things like this is there are gray areas in between. So it's not just on or off, but rather this feature is enabled for internal admins only. Or this feature is now enabled for any of the users that I whitelist that are allowed to have it. Now it's enabled for 1% of users, 5% of users, 10%. And you can do ramp ups as you're releasing new features and do testing on that. So you can put a feature out there, you test it for admin only, just have kind of your internal developers hitting that, but they're actually hitting it live in production, but none of your actual customers are actually hitting that. You hit that, it looks good, there's no errors that you're seeing. All right, let's ramp that up to 1% of users. Oh wait, errors are showing up. Now let's flag it off, let's fix the bugs, things like that. Now this is not a replacement for dev and QA and staging environments and things like that. This is in addition to that, right? So you push your code out, you test your code locally in dev, you put it out to staging, you test it there, then you put it out to prod and you still have the capabilities to test it and to slowly ramp that feature up over time. That's what enables us to do things like push to production 30 times a day or so on average. So this is not like 30 commits. Each push to production can have 5, 10, whatever numbers of people actually involved in this. There's a bunch of slides actually online talking about this entire continuous deployment push cycle and things like that of how do you actually, what are the mechanics actually involved here? Because it's pretty interesting. You have people joining internal IRC, like the internal IRC push channel, and they coordinate via that, and everyone says they're good, they go out to like staging, they test on there, watching graphs, things like that. You push out to production, everyone watch graphs, make sure things are actually working, and then you hand it off to the next group. And you're able to do that fairly quickly to the point where you can push to prod 30 times a day, right? And compare that to environments that we've all been in where you're pushing to prod, what, 2 weeks, 6 weeks, 6 months, things like that, right? We've all been in environments where pushing stuff out the door takes a long time. Being able to do like fast, frequent changes to prod is great because it enables me to use the cutest slide I've ever had in a talk, which is using a puppy to actually push the enter key to push to production, which is quite awesome. So aside from being the cutest slide I've ever gotten to use, the important point here is that pushing to prod is not that terrifying experience that it usually is in most environments, right? If you're pushing to prod every 6 months or so, everyone is scared because everyone knows it's going to break, right? If you're only going to prod so often, you know that the developer who wrote the code wrote it 6 months ago. It went through QA 4 months ago. Now the ops group is pushing it out there, but they don't actually know what's going on in the code, right? It's divorced at every cycle from who's actually involved, compared to developers actually pushing to prod and having direct responsibility for not breaking the site when they push code. So, as a security person, this was me on my first day, right? You're 30 times a day going to prod, that's totally insane. This is going to be a nightmare from the security side. I've come around from thinking exactly that to now drinking the Kool-Aid and now standing on stage talking about the Kool-Aid and selling it. Because the opposite is actually true. Being able to push to production is actually our #1 security feature. And the reason for that is compare it to other models, right? Compare it to, well, read this and take a look at what the one word in bold on here is, right? Former. Because this is one of the key takeaways of this talk actually, is that every one of our development methodologies has vulnerabilities. So how do we reduce the time to actually fixing those, right? If we have a cross-site scripting and we have one environment where we can push that out in a matter of minutes compared to another environment where we push that out in a matter of weeks or days, weeks, months, years, it's the same vulnerability. Have the ability to actually respond quickly to that. So the core of the talk. This is kind of going through starting from the beginning of the software life cycle, if we're going to throw some sweet buzzwords out there and say SDL and SDLC and that sort of stuff. I think I have to drink every time I say that or something. So we'll start at the very beginning here. How can we make things safe by default up front? As we're writing code, how can we figure out, as the AppSec team, what is the riskiest stuff that we want to actually know about, that we can focus our efforts in on, because there's more code going out there than we have time to actually look at. I used to call this third section here automate the easy stuff. That's wrong. Automate as much as you possibly can, right? You should be taking a look at this and as your daily actions as not just an AppSec team, but as a development and operations organization. How can I automate as much of this as I can so I can focus on other areas? And then finally, how can I do things like graphing and alerting and know when all of my previous sections have failed? So at each point throughout here, how do I start with one thing and try to make it safe? And then how do I know when that has failed? How do I know when that has failed? And how do I know when that has failed? And try to catch things at each point throughout. So we're going to talk about safe by default at first. And I'm going to specifically focus this on XSS. We could talk about this all day for every vulnerability class out there. I want to focus in on XSS. So how has traditional stuff worked out? I have a highly technical diagram after this that illustrates modern web applications and cross-site scripting, and if you'll bear with me, this exemplifies web applications, and this would exemplify cross-site scripting. The point being, there are problems. There are always problems as far as cross-site scripting. So I spend a lot of my background in offensive work, in penetration testing and things like that. And this list could go on for a mile here. I think every developer here, every security person here could list this out for a dozen slides, right? You see problems of things are done like ad hoc, right? It's on per inputs. It's done maybe at a framework level, but for the wrong context. So that was great when your application needed to defend against full HTML injection, but now suddenly you're taking user input and you're injecting it in JavaScript, and it's a completely different set of characters you need to be worried about. You may have things like putting defenses out there on the client side where they're just bypassable. The point is that list can go on forever, and all of those problems miss the point entirely. The real problem, and the reason why AppSec, specifically for this vulnerability class, has always been so hard is that it's very hard to find where in your application protections have been missed. Right? This is why you have things like static analysis tools, dynamic analysis tools, penetration testing, things like that, is because it's not a trivial task to find out where these vulnerabilities are and where your protections have been missed. This is what I think we should be doing, is how do we change our approach to this to make it safe by default, but to make it simpler to actually detect these vulnerabilities. So everyone, seriously? Woohoo, all right, escape it is. Apparently the bottom button on this thing is the self-destruct button. That is good to know. The top three are good. First one's laser, bottom one is self-destruct. I feel like Dr. Evil, it's great. Okay. Input validation, output encoding. We've seen these terms 20 million times, right? Let's look at them from a completely different approach here. And let's look at input encoding. So, what this is about is encoding dangerous HTML characters at the very start of your framework. So if you have kind of conceptually here, user input coming in, it goes in at kind of at the top of your stack, let's call it here, your framework. User input comes in, it goes through your framework code, and then it works its way down into kind of your application code. So your application code being your feature stuff, everything like that. Everything that it inherits is up here in your framework. So at the very beginning, at the top of your framework here, when user input comes in, escape all of the HTML characters to their HTML entity equivalents. So before it touches application code. This doesn't seem like that much of a change up front, right? This is just a kind of mishmash of those two approaches. Except this actually makes XSS greppable across your code base. You're not doing static analysis anymore, you're not doing dynamic analysis, you're now grepping for XSS in your code base. Kool-Aid guy, oh yeah. This joke does not work in Europe, by the way. American cultural references. All right, so I said grep. What are we actually grepping for? The main thing that you're grepping for here is number one, by far number one here. You're looking for, if your data is in, if your user input is in a format that is safe by default up front, you're looking for places where it's made unsafe. So if it's encoded, you're looking for decoding functions. The other caveats here to think about are if your data is coming in a format that's not just normal user text, HTML, that sort of stuff, if it's base64 encoded, if for some reason you have some weird function that or some weird feature that double URL encodes, which we've definitely seen. This list can go on forever, but data in formats that are not your standard format, you grep for those as well. Because if you're doing a base64 decode, that means your input is base64 encoded, that means it didn't get sanitized in the way that you expected. And then finally, code that opts out of platform protections. That almost never happens in most modern web applications, I would say, because if you're doing something like that, that's a completely one-off page that isn't really able to interact with the rest of your app at all. Because it's not that you're opting out of platform protections, it's that you're opting out of your framework entirely. So any of your code that's opting out of your framework really isn't doing anything in your application. Like I said, this very fundamentally shifts us from where is my app missing protections, which is an incredibly, that's hard with a capital H problem to solve, to where is it made deliberately unsafe, which shifts to grep. This has some interesting caveats here as well. DOM-based XSS, this was by far, as far as XSS, our biggest vulnerability class that we saw out of XSS here, because you're dealing with user input that's being rewritten into the DOM that's not even going to the server. So it's not sanitized, it's going to be happening in the browser there. You're going to be, this isn't going to protect you against DOM XSS. It's not going to protect you against some weird cases like JavaScript URLs, right? If you're constructing URLs off of user data, JavaScript alert1 is not HTML entities that are going to be actually encoded there. And then append during internationalization efforts. There are three things that love the single tick. XSS inside JavaScript, SQL injection, and the French language. Those things all love single ticks. Things to think about when you're internationalizing your site and dealing with foreign languages. Okay, so we started out, how do we make framework level decisions that make things safe by default? How do we now know where we want to focus our efforts as code's being written, as code's entering the code base? This top point is absolutely true, but this whole slide section actually doesn't really matter as far as continuous deployment. No matter what, things are going to go out the door before security knows about them, no matter what your life cycle is. Whether it's 6 months or 6 hours, I guarantee you any security team there is going to nod vigorously when you say, are things going out before you know about it? The answer is yes. I mean, half the time things are going out before product knows about it or other groups know about it too. So, how do we actually know about what we want to focus in on? I'm going to talk about 3 things in here, 4 things total. 3 things of as code is entering your code base, and then 1 thing as far as when your code's actually running in production. So we're going along the stack here. The first one I'm going to talk about is just knowing when sensitive portions of your code base have been modified. So this really goes back to the thing I'm talking about of what are very simple, effective things you can do. As far as simple, it doesn't get much simpler than just running a hash on a file, right? So if you identify, to go back here, you want to identify sensitive portions of your code base. You want to do it at the platform level and at the feature level. So first I'm going to talk about platform level. And you want to know when those features actually, or excuse me, when those platform files actually get modified. Because when you're doing things like your CSRF defenses, your session management, any sort of wrappers you do for encryption and things like that, those are pretty much write once, update almost never. Right? You're not that often changing your CSRF defenses. You're trying to put them in place everywhere, but you're not messing with the core logic of that. As an AppSec team, this is something you want to know about if anything changes in there. Because if anything changes in there, it should be you making the change because it's a core security library. So, identify those files. A simple way you can do this is just identify them, SHA the files, alert if the hash changes. Have a unit test that runs every however many hours. It stores the hashes of all those files. If it's a different hash, alert. You could easily build this into, depending on what your source control mechanisms are, just alert out of that if anything changes, if anything gets committed to those files. Like I said, these are good areas to do at the platform level. At the feature level, you're looking for very specific methods. This is where it gets a little bit trickier, because what you're looking for in a feature is not the entire block of feature code, right? It's no longer at the file level, it's much more at the method or function level, because you're shipping a new feature, there's going to be lots of like UI changes that are happening all the time, things like that. You're not so concerned with those changes for this stuff. What you're worried about is, did the core business logic change, right? That's the stuff that once it gets written probably doesn't get messed with too much, and you're just doing the UI changes around the feature. So identifying these sections of features is part of the initial code review, design review, pen test phases of your code. You come up with the list of kind of what I should be watching out of this feature, and then you do this alerting off of those sensitive parts of the features. Watching for dangerous functions as they show up in the code base. Static analysis tools excel at this, right? This is grep. That's why they excel at this. So it's your usual candidates here, right? It's file system operations, it's shell execs, it's this one I didn't have up here at first. This is one that we learned over time of, as you're seeing encryption or hashing functions show up in the code base, that's almost always something that you want to go check out. Because what we've typically seen there is developers with the best intentions knowing that they should be protecting this data somehow, but they're not exactly sure how, right? And unless you're a security expert, talking about the details between different crypto methods, crypto just encryption versus hashing versus different approaches at all is kind of the magic crypto dust, as one of my former bosses used to say, right? I know I can sprinkle some crypto dust on it and it'll be okay, except it's not usually okay. So as a security team, alerting on that and going to development teams when you see it and say, hey, I noticed you're using an HMAC on this. What are you guys actually trying to do? And it's like, oh, we're trying to either protect this data from manipulation or we're trying to keep it confidential or what. But you can typically have really good conversations out of seeing encryption or hashing show up. And actually sometimes you can get cool wins for the dev teams by, if it's the reverse, if they're like using AES or some sort of crypto and actually all they need is hashing on that, they just need an HMAC, you can actually get performance wins out of that. And it's pretty awesome to be a security team giving performance wins rather than performance hits. It's a rare feeling. Awesome. So what we found actually useful out of looking for dangerous functions in the code base is splitting that out into high risk and low risk lists. Now, risk is actually a misnomer here. That's more around kind of internal SLAs. So a high-risk one might be high risk in your environment, and your AppSec SLA on that is maybe a day for a code review, where a low-risk one is maybe 3 or 4 days. It's not always the ones that you would expect up front too, because we've seen cases where there are functions that are very high risk in terms of just absolute measures of risk, but for whatever reason they show up in your code base a lot. Dev teams work with them fairly frequently. They know how to do them safely as a general rule, and that may then slip into your low risk category because on average you see a fair number of them, they're used correctly. All right, let's give a bigger window there and let's focus on other ones that maybe show up almost never. So if they do show up, something's weird about that. That should be in the quick turnaround SLA. Just like everything else here, as these things show up, these alerts go to the AppSec team. So I could actually diverge on this topic for a million years actually, but I'll just do it for 30 seconds. So we've made a very conscious choice that all of these alerts that you see out of here go to the security team, not to dev teams, because we've made the cultural choice, for now anyway, we'll see how it goes when we scale, but for now that we want the development interaction with security to be when there are real issues. We've all seen environments where automatic alerts and automatic like vulnerability findings and things go directly to developers, and that's where you get in a situation of here's a Fortify report with 10,000 findings, deal with it, and it's a report this big on your desk, and as a developer you're like, I don't know what this means, right? I don't know which ones are actually real. I don't know what I should actually do with this information. What we've gone with is have that data, take the hit on the security team side, and go to development when you have real issues. So that if you're showing up, it's a real thing. It's not a false positive. It's something that's been vetted. It's something that should actually be fixed. All right, thanks for bearing with me on my rant. This was really interesting. So this, again, like everything else, seems super obvious. But we had a pen test a few weeks ago, and one of the most interesting findings out of that was that 2 of our most severe findings were in completely dead code that nothing was using anymore. It was a file sitting out in htdocs that nothing touched, and it had serious vulnerabilities in that. And so it was great because the remediation was we just deleted that file. That's the quickest remediation ever. But the point is that that shouldn't actually be there to begin with. So what we did out of this was we created a script like this where we walk through kind of the document root of the application. We build up a list of all the files in there. Then we query that against our access log and we say, was this file, how many times has this file been accessed in the last 30 days? Okay, is it above 1,000? All right, it doesn't matter, that's live. Is it less than 1,000? That's interesting. That's something that's not really being touched. Is it less than 10? Is it 0? That's something that all of these things should definitely be a manual review at the lower numbers, and almost certainly it can just be removed entirely. Like I said, kind of back here, this is a big case of that temporary code in production, right? Like I'm releasing this feature, I need some other code in production there to kind of test it out and do some stuff live in prod. I'll delete it when I'm done, and then we've all been guilty of this, you move on and you forget. So seeing what's not actually being accessed but is still reachable turned out to be an incredibly valuable script that we wrote out of this. So that says code is entering your code base and staying in your code base for perhaps too long. The next phase I'm going to talk about here is looking at application traffic. So looking at code that's actually live and out there in prod. The 2 main points of this are detecting risky functionality, stuff that was missed by previous systems, and then laying the groundwork for some of the more interesting systems I'm going to talk about later on. So this first bullet would make me like facepalm if I was sitting in the audience. Shockingly, this actually works and works very performant of regexing incoming data at the framework level and looking for HTML. Taking all user requests coming in, taking a look for HTML in there, and building up a list off of that. So it's not so much that this creates false positives as this creates a huge amount of data that's very much by design. Because what we want is that aggregate amount of data, and then we can siphon it off and look for specific things later on. So we want to see where HTML is just entering the application in aggregate. And what we want to build off of that are 2 interesting things to allow us to do anomaly detection. We want to see where in the application this data is actually headed. So all of the endpoints, right, it's headed to /A/B/C. And then just in aggregate, how much HTML is actually entering the application. Because what you can start to do off that is some interesting anomaly alerting on, did a new endpoint just suddenly show up? Or did traffic containing HTML suddenly shift up? So not spiking, because spiking is going to be somebody running an XSS scanner against you, or just a spike of traffic because you got slashdotted or hacker newsed or whatever the kids are doing today. That's going to be temporary blips. But you're looking for sustained shifts here. So this is what you're looking for. Your graph suddenly does a long sustained shift up of HTML entering the application. If you didn't know that a feature was going out the door that was going to handle a lot of HTML as user input, now you do. And now it's time to go back and do pen tests and code review and things like that. Both of these things that I'm talking about have found real vulns and real features in our app that we didn't previously know about. The endpoint one gets a little, you have to make better alerting on that over time, because you're just going to, as your app scales, you're probably going to have more and more and more endpoints. But basically doing diffing on that with some logic around areas where you expect new endpoints and kind of weeding those out, and then alerting off of things outside of that list. This one, for example, was a feature that legitimately handled tons of HTML as a user input. We didn't know about it till that graph suddenly spiked one day. We went through, we then pen tested that, code reviewed that, pulled a bunch of good vulnerabilities out of that, and made that feature more secure. So what gives you the time to actually do any of this stuff? Automation. How do we automate to actually have the time to do these things? And this is something that we call attack-driven testing. So if you're on the internet, congratulations, you have free pen testing of varying quality all day, every day. Congratulations. Why not harness that and get some actually valid things out of there? If you have people looking for vulnerabilities all day, why not actually get some free stuff out of this? So this is useful it's probably useful in more things than this, but the three that I'm going to talk about are application faults, XSS, specifically reflected XSS, and then SQL injection. So application faults. How many people have done some sort of offensive pen testing, specifically for web apps, I'll say, in their past or current life? People? Yeah? Okay. When you get HTTP 500 errors out of an application that you're testing, it's awesome, right? It's like the smoke before the fire. It's the ka-ching moment, because you know you're about to pull some good vulns out of that. As a defender, if you saw how excited we all just got as attackers by that, that's probably something you want to know about, right? So the approach for this, and what we do out of 500 errors, is just alerting off of 500 errors is essentially meaningless. You're going to get tons of these things. You're going to get these just with a one-time random failures in the app, with maybe a production web server that's just failing, like its memory just failed and it's totally crashing on the way out, and you're getting a stream of these things. There are tons of random scenarios where you'll get one-off 500s. So the way to actually make this data valuable is collect all of those 500s for, let's say, the last 12 hours. Wait 6 hours, 12 hours, replay them. If something still triggers a 500 from that same request 6 hours, 12 hours later, that's something worth actually checking out. What's interesting about this one is, just to give you guys some context and some actual numbers on this, we see this alert go off maybe every 2-3 weeks, maybe 2 to 4 weeks, we'll say. It's really rare, and what's interesting is that it's always real bugs. So we've actually never seen a single security vulnerability come out of this report. We've seen real bugs come out of it every time. So it's actually kind of interesting. Yeah, it's fun stuff. Similar methodology for verifying reflected XSS. So let me give you a brief, embarrassing detour on this. So back in the beginning, when we first started looking at identifying XSS requests coming against our app and taking a look at those, one of the first things that we did is just kind of generate a list of XSS attempts people are trying against us. As one can imagine, that doesn't scale very well. But what's interesting out of that is you could visually you can very easily identify what are legitimate XSS attempts and what are people just running scanners and generic things you don't care about. So one of the things that we would do is, oh, that one looks interesting. I'm copying and pasting this out of an alert and trying it in my testing browser and seeing if something pops. Copying and pasting a URL and running it in a browser, if there's a better case for automation, I don't think I've ever heard it. we did that a couple times, and they're like, why would we ever do this? Let's automate everything that we can out of this. So going back to that original regex stuff that I was talking about of entering, identifying HTML, entering the application, then taking a look through that data that's coming in and look for things that are likely XSS. It doesn't matter if you're 100% here. I mean, even just 90% is awesome. Looking for basic XSS payloads. So here's a list. The real list is, you know, way longer than this. But what's interesting is the way that people actually test for XSS is very common payloads. People do different payloads inside of alert and things like that. But by volume, the vast majority of people testing for XSS are using things like this. So you identify this sort of stuff. You tag it as a request that you want to know if the XSS succeeded. Because what you're actually trying to figure out here is, did this succeed? Did this JavaScript execute? Because I'm not calling unescape in that parameter in my application, but the attacker sure is trying to. So we did this a few different ways. The one I'm going to talk about is Node.js. We made a headless browser to basically replay these requests and do it for us. So you identify the request as kind of step 0 here. Step 1, you fetch the URL containing a potential XSS against your web server. Now, you don't interpret it right away. You dump it back to a temp buffer, and what you do from there is you inject instrumented JavaScript into that buffer. You prepend it at the top of that page content that comes back. So what you're actually instrumenting are all of these. Anything you identified as you want to know about, instrument that, inject it into the response now, and now interpret the contents here. And what you're actually looking for out of this instrumented JavaScript is, did this code execute? You don't care about what it did or things like that. You want to know if I identified this as a potential XSS request because it's calling alert 1, did alert execute? If it did, I want to know. So instrument it, now run it. If it alerts, email the AppSec team. Any talk that gets to use a Jurassic Park slide is okay by me. Okay, it can be as simple as this. So override alert, say if I ever execute, just set location to XSS detected, interpret that body, check location. If location is XSS detected, great, you just got a free vuln out of that. We open sourced the early version of this. We've since actually rewritten it, and I hit the self-destruct button again. All right. We've open sourced this. We've since written a new version that I'm meaning to put up on GitHub. If you want a copy, just drop me an email, and I'll just send it directly to you. The point to know out of this is just instrumenting like using Node.js or Phantom or any of these only gets you a little bit here, because what's interesting about browsers is what pops in one may not pop in another. So you actually want to combine this with instrumenting as many browsers as you actually can via things like Water or Selenium or just any of the toolkits to actually drive a browser. And then you want to replay it across all your browsers, because what's an XSS in IE may not be an XSS in Chrome. Cool. Final big section. Know when everything's going wrong. The easiest way you can do this is by graphing. So, like it says, of the next 2 slides, which of these is a quicker way to actually spot something going on in your app that you want to know about? Is it watching your access logs, or is it watching that happen, right? You can put this up on a TV, see that, and be like, all right, time to go check out what's going on. So your methodology for this is pretty straightforward. You need to instrument your application for as many data points as you can think of. Instrumenting should, I'll jump ahead and jump back here a few times, but instrumenting needs to be very simple, otherwise it's just not going to be done. So we've open sourced our library called statsd because it's literally one line to instrument your application here. You put in a statsd call and you say increment this counter or decrement this counter, and then you not even sprinkle these, self-destruct. All right. Not to sprinkle these through your application, but put them in as many places as you can possibly think of. Because you don't need to look at all that data, but you have to have that somewhere, because there will be a time when you need it. You probably don't need it on a day-to-day basis or month-to-month basis even, but there will come some sort of interesting outage or vulnerability or something where you need that data that you thought that I don't need to actually instrument this part. So instrument as much as you can. That goes off to a back end, which actually aggregates this data. So that would be, okay, so like Graphite here. So that'd be Graphite. Graphite is a great tool, but it's not so awesome to actually go in through there and actually look at your data that way. It's good for like testing and deployment and stuff like that, but actually using it on a day-to-day basis to drill down into your data isn't as useful as we'd like. So from Graphite and from your back end, build individual graphs off of that. Build the graph that you just saw here. Now what's most important is not just building that graph, because I sort of lied a second ago when I said you want this. You do want this, but this isn't all that you want. You want this, right? Because this graph doesn't tell you as much as you think that it does. This tells you login failures are occurring. It doesn't tell you, is it bad usernames? Is it bad passwords? Is it accounts that you've frozen? Is it invalid emails? What is going on? And this is what I'm really talking about when I'm talking about instrumenting all those data points. Don't just instrument at your case where login failed, all right, now increment that counter. You want to do that, but you also want to, on your switch statement of why login's failing, instrument at each point there, so that you can drill down into this and say, okay, it's a spike in wrong passwords, or it's a spike in completely invalid usernames, or what, and actually get that data out of your application. So now we can actually visually spot attacks. This is great. It's fantastic. You can put this up on a TV, like up on a dashboard, put it near your security team, and when something spikes, you guys know what's going on, you can check it out. The problem is no one's actually sitting there at 4 a.m. So we need ways to actually get alerting off of these mechanisms. It's very simple for graphs like this. If you have a graph that should be 0 all the time, it's very simple to say, if it's above 0, alert. It's not so easy to do graphs that follow normal usage curves, right? So this is sign-ins over a day, and of course during the middle of the day it's going to be higher, at night it's going to be lower. You can't build effective alerting off of this, because if you're just looking for spikes, a spike here does not go as high as a spike here. So your thresholds are totally skewed all the time. So what we need is a way to make that second graph look like that first graph. And what you can use are things called exponential smoothing formulas. What they do is exactly that. They turn a graph like that and they build confidence bands around that based off of your past data. So if this is a normal usage curve that goes on like that, it goes up in midday and goes down at night, it looks at your historical data there, it builds confidence bands around based on the past what it expects your data to look like, and then it draws spikes off of that axis when it's going outside of those confidence bands. Cool, so we flatten the graphs and now we just get spikes when there's something outside of those bands. Now we can use the exact same approach. We can completely reuse our code here and grab the raw data out of this and say, okay, now if it's spiking above the threshold, now alert. So the devil in the details on this one is coming up with those thresholds. In our case, that took about 2-3 weeks or so, I'd say, of what you do. You just kind of treat this as debugging. You come up with a threshold, you set it arbitrarily low, and you have the alerts not set off the security pagers, but just send you an email or something like that. And then you wait for it to hit, and you look at the spike and say, okay, now I want to adjust it a little higher, a little higher. Hopefully one of two things happens. Hopefully you either have historical data for a real attack, so the real anomaly you're trying to look for, or hopefully an attack for this category actually happens during that time when you're instrumenting it. And you can say, okay, this is what a spike actually looks like. This is a real threshold above which it's certainly an attack. I can set my threshold here. Have the ability, so alerting, like graphing and alerting is great because it lets you know there's a problem. Now you need to start digging in and finding out what that problem actually is. So having the ability to really quickly correlate events across your application is key on this. One of the things we do on this is just tagging each request with a global request ID. So when it comes in, at the very beginning of the application, it tags it with the request ID, and that request ID then follows it through the application. So you can get something like this where, we'll start at the top. So this is like your access log, right? And it's tagged with the request ID, and then there's some sort of info log, and then another info log, and then maybe an error log. But what ties it all together here is this unique ID. Because you almost never go from the top down in this. You're not tracing requests through unless maybe you're debugging something. When you're investigating incidents, you're investigating errors and things like that. You're starting from the error, and you're saying, okay, I now have the error in my error logs. I want to know what caused that. What was the request that actually did it? So you trace back back up your stack across your info logs back up to your access logs and things like that. Final section. The great thing about events that should never happen is that they do. So have alerts for them. Attacks. So it's not so much a misconception, but kind of a popularization of attacks just sort of happening. But that's not how they actually happen in the real world, right? It's not that you have a form field that was vulnerable to SQL injection, and so suddenly your database is on pastebin. It's that someone had to find that vulnerability. They had to find that there was some weak parameterization of input validation going on. They had to enumerate your schema. They had to refine their attack and actually extract that data. So what you want to do as a general category here is figure out what signals are for each vulnerability class that you're worried about. What does a signal look like of an attack, of a vulnerability being discovered or an attack being performed actually look like for a given vulnerability class? And then put alerts in place when those signals actually happen. So then you get a signal, hopefully before an attack is actually completed, and you're able to fix those weaknesses. So I'll give 2 examples of SQL injection and 1 of code execution. SQL injection, as I kind of said a second ago, from identification of a weakness to dumping the full password database, there's a lot of broken SQL that's happening between A and B there. A and Z probably. So one of the simplest things you can actually do off of this is alert off of SQL syntax errors. We do this and have tremendous success with this actually. We found 2 SQL injections in the last, say, month and a half off of this alert specifically. And to give you an idea of volume, it's probably 1 every few days, and that's because we're deliberately keeping the net even wider than it really should be. If we focus this in on just the class of things we should really be worried about, it's probably once every 2 weeks or so, I'd say. And at that point, I mean, the volume of actually just looking at these alerts is nothing. You can look at one of these alerts, look at the SQL syntax error and say, yeah, that's a real thing, or that's nothing I need to be worried about in a second. Further along the attack chain for SQL injection, a SQL injection attack looks shockingly like your database if they're dumping your database out. So if you have unique table names in your database, those should almost never be showing up in requests. This is the one that we call the 2 hours until pastebin alert, right? Because if your user like login details table, sessions table, whatever, is now showing up in your login form field GET request, something incredibly interesting is going on. So if you can build up a list of what your table names are that are actually unique, alert off of that just showing up even in your access log, and then alert and investigate when they do, you can get some pretty powerful detection mechanisms. So, an interesting story about a PHP code execution vulnerability. So, regex replace in PHP is this function called preg replace. There's the whole definition here. The interesting part is this part of the definition, which says that if the E flag is set, evaluate everything inside here as PHP. So turn preg replace into shell exec. Awesome. What do the signals actually look like of a real attack here? They look like this. So if you're building up the modifiers to preg replace off of user data in some way, and now user data is triggering unknown modifier errors for that, that's pretty interesting, because if that C was actually an E, that means execute everything after here. And the bottom line of all of these identifying these signals is that you can't fix what you're not alerting on. And that's pretty much it. So this slide I love because I feel like it sums up the security industry pretty well for me. I love it. Have the ability to deploy and respond quickly. We all have vulnerabilities. It doesn't matter what your software lifecycle is actually like. If it takes you 18 months or 18 minutes to fix a vulnerability, it's the same vulnerability, be able to actually respond quicker for that. And like I said up front, start by making things safe by default up front. Figure out where you need to focus in on, the exceptions to that. Automate as much as you can so you actually have the time to focus in, and then know when everything along the way has completely failed there, and there are things that you need to actually look into because you missed it via previous mechanisms. You're awesome. Thank you. Questions? Yeah, all the way in the back. the question was, when you bring on new developers to the engineering org or a team, how do you educate them to a security mindset? That's something that's kind of done from the top down. I can obviously only speak for our culture, but it's definitely something that's seen as, what I like about how we approach security is that it's seen as a subset of good engineering. So it's not like, security is not the stick, it's not the checkbox that you have to get the security check to go ship to prod or anything like that. It is that, in the same way as performance, in the same way as reliability, security is part of good engineering, right? You wouldn't release a feature that blows out your page load time by 3 seconds, in the same way that you wouldn't want to, if you see yourself as a good engineer, you wouldn't want to release a feature that has SQL injection in the login form, right? So once you categorize it as good engineering, and you have engineers who pride themselves on being good engineers, it kind of just becomes part of the mindset. To give you a little bit more specific example out of that too is, as you have new developers coming on, and they may not be used to that or things like that, as they're shipping features, leads typically ask like, okay, cool, what did security think about that? And like, your first time as a new developer is probably, I don't know, I didn't talk to them. And that's like, okay, great, well, go talk to them, see what they say. From the security side, and this is a whole kind of security culture sort of answer here that I'll veer into, but on the security side of that equation, you need to not become the blockers, right? You can't have development groups coming to you proactively, and your response being you can't ship that feature, because that'll work really great that first time, and then you'll wonder why no one ever shows up again, right? You need to treat it, I keep drawing parallels to the performance group, but I really like that a lot of, you go talk to the performance group before you ship, you go talk to the security group before you ship, because you want to ship good code, and secure code is good code. Questions? More?
Okay.
Yeah?
What was the state of security at Etsy when you first arrived, and how long did it take you to get to this point?
Oh man. What was the state of Etsy security before I arrived, and how long did it take? That is like the greatest ego lead-in question of all time. Well, obviously it was terrible, and I showed up and everything was great. No, actually, I'll trash on myself for a moment, actually. So the framework level defense I talked about for XSS, so the input encoding, that was in place before I even showed up. I have a bit of an interesting answer to that, because I actually did the pen test for Etsy way back before I actually worked there. So I've kind of seen it come along. But it's really interesting, I would say as the engineering organization has matured, so has security. I really tie it to an engineering organization that prides itself on doing good work. Security goes right hand in hand with that. Was that too big of a dodge, or does that answer your question? Awesome.
How long have you been there?
I've been there 2 years in, I think, next month. Keep it going. Questions up front.
I assume that a lot of the stuff that you're implementing there is stuff that you've learned throughout your career. But where's kind of the bulk of the stuff that you're doing there? Is that stuff that as a group at Etsy you've sat down and kind of come up with this stuff, and you've gone to different meetings, different groups, and picked up this stuff?
Right. So the question was sort of how do you come up with these approaches? How do you put these in place? For everything I talked about in here, there's 10 things that failed, right? And even as a general engineering approach, you want to fail fast, right? How do I put ideas out there? Every unit test I talked about, there's probably 3 that we turned on and it blew up alerts against us and it gave no value and we shut it off. So in the same way that continuous deployment is iteration, AppSec at a fast-moving org or at any org is totally iteration. Yeah, you definitely try things and they fail, and you move on from that. And actually, that's good. That's something I wanted to talk about actually, which is out of these alerts that go to the AppSec team, if you're comfortable with those, that's something that you shouldn't feel comfortable with those, right? These alerts that are going to your AppSec team, they should annoy you. You should be annoyed both at the level of false positives, at just the general volume of alerts coming in, and at what they're missing. Because if you're not being annoyed by your alerts, you're not actually changing anything with them, right? How do I adapt my alerts over time to find more interesting things, find it more effectively, reduce the false positive rate, only page me at 3 a.m. when it's something real? Keep it going. Heckling, even? Loud shouted boos? More questions? All right. Thank you for coming. Thank you to Box for hosting this.